Good morning everyone. Myself Swaroopa. I am working as an assistant professor in CMR Engineering College. I am dealing with operating system subject. In that there is a CPU scheduling algorithm. There is a topic CPU scheduling algorithm. So before entering to the types of CPU scheduling algorithm, let us know what is meant by CPU scheduling. So CPU scheduling is dealing with the process which are available in the ready queue and which are going to be executed. So that is about CPU scheduling. The main objective of CPU scheduling to maximize the CPU and how all processes are executed in correct manner. So that is the main objective of CPU scheduling. And the types of CPU scheduling, there are two types of CPU scheduling. One is the non-preemption, another one is the preemption. So coming to non-preemption CPU scheduling, there is no interrupt for any process. That is non-preemption CPU scheduling. And coming to preemption scheduling, there is a interruption. So that is the preemption scheduling. And the types of non-preemption scheduling, FCFS. FCFS stands for first come, first serve. SJF stands for shortest job first. Priority. Again, in priority scheduling, there is a two types, with preemption and without preemption. And coming to primitive scheduling algorithms, types SRTF, shortest time first, and round robin. So these are the two types of CPU scheduling algorithms are there. So we will see before entering to the problem, let us know what are the performance criteria we have for CPU scheduling algorithm. So first, throughput. What is mean by throughput? A throughput is nothing but number of processes are executed per unit time. That comes under throughput. Next, total turnaround time. How much total amount of time the process has taken to complete its execution. That comes under turnaround time. The turnaround time can be calculated complete time minus arrival time. And waiting time. How much amount of a process has waited in the ready queue to get CPU. That comes under waiting time. And complete time. What is mean by complete time is how much exact amount of time the process has taken to complete its execution. That comes under complete time. So we will see FCFS. So what is FCFS? It is one of the non-primitive scheduling algorithm. FCFS stands for first come, first serve. So the name itself says that which process will arrive first, that will be executed. It follows FIFOs. FIFO means first in, first out. So that is the FCFS. So there are 5 processes which start from P0 to P4, and there is a arrival time, there is a burst time. So we need to calculate complete time, total turnaround time, and waiting time. So these can be the calculation to how to calculate the complete time and turnaround time, waiting time. We can calculate by using Gantt chart. So what is mean by Gantt chart? A Gantt chart is a visual representation and which consists of horizontal bars to represent each and every process execution. So first we will start with process P0. So what is the arrival time for P0? 0. At 0 second, P0 has arrived. And how much amount of time it taken? So here burst time is nothing but how much amount of time taken by process. So that comes under burst time. So it takes 3 milliseconds. So P0 will start at 0 and it will take at 3 milliseconds. From 0 to 3, the remaining process means P1, P2, P3 as P1, P2 all as P1 has arrived. But we have to check based on arrival time. Next, we need to consider arrival time. Next, which process have less arrival time? P1. So how much amount of time it takes to complete? 6 seconds. So P1, 3 plus 6, 9. Now the process P2 at 9 seconds, P2, P3, P4 has arrived in ready queue. But we need to consider which process have less arrival time. So among all 3 processes, P2 has very less arrival time. Now P2 will execute. How much time it will take? 4 milliseconds. 9 plus 4, 13. Next, again process P3 as P3 will allocate it to CPU. How much amount of time it takes? 5 seconds. 13 plus 5, 18. Next, process P4 will execute next. How much amount of time it takes? 2 seconds. So, 20. Now, these are the complete time of each and every process. So, process P0 will execute at 3 seconds. Will complete its execution at 3 seconds. P1, 9. P2, 13. P3, 18. And P4, 20. Now, we need to calculate total turnaround time and waiting time. Already we know that what is total turnaround time? It is the difference between CT minus AT. CT is nothing but complete time. Already we know that CT and AT. Already arrival time as given. Now, first for process P0, total turnaround time equal to CT minus AT. So, what is the CT? 3 minus 0. 3. Next, 9 minus 2, 7. 13 minus 4, 9. 18 minus 6, 12. 20 minus 8, 12. So, this is the turn around time. Now, we need to calculate waiting time. So, waiting time equal to turn around time minus burst time. We need to do the difference between turn around time and burst time. So already we know that turn around time and this is the burst time. For process P0, TAT minus BT. So what is the TAT? 3 minus BT. For process P0, 3. So 0. Like this we need to calculate for each and every process. 3 minus 3, 0. 7 minus 6, 1. 9 minus 4, 5. 12 minus 5, 7. 12 minus 2, 10. So, this is the total waiting time and total turn around time of each and every process. Now, we need to calculate total average turn around time. So, total average turn around time, total turn around time by number of processes. So what is the total turnaround time each and every process? 3 plus 7 plus 9 plus 12 plus 12 by number of processes. What are the number of processes we have? 5. Let us say, so the total turnaround time 43 by 5. So the average 8.3 milliseconds. So this is the total turn around time. Average turn around time of each and every process. Similarly, average waiting time can be calculated by total waiting time by number of processes. So total waiting time P0 plus P1, P2 up to P4. Number of processes 5. Like this, we need to calculate average turnaround time and average waiting time of each and every processes.